Hello guys, welcome to the lecture 7 of machine learning series. Till now we have seen what and why components of machine learning. But in this video we'll be discussing how to build an end-to-end machine learning product. Okay, we have software development lifecycle. Similarly, to build an end-to-end machine learning product, we also have machine learning development lifecycle. Okay, in this machine learning development lifecycle, we basically have 9 points, and then this 9 points we have sub-components. Okay, now this 9 points are the roadmap for our further videos. Okay, now our further videos in the playlist will be on this 9 points. Okay, now first let's go through our first point, that is framing the problem. Okay, now before taking up a machine learning project, okay, first you need to understand what problem it actually solves. Okay, what data set should I use? Okay, should I use the image data set or else some tab separated values dataset or CSV dataset? Okay, what kind of dataset should I use? Okay, and is it supervised learning? Okay, should I use supervised learning or unsupervised learning? Should I use batch learning or online learning? So basically we prepare a questionnaire over here. Okay, we basically prepare questionnaire over here. Okay, we prepare a questionnaire and some related answers to it. Okay, we particularly prepare some questionnaire and we write some related answers to it. Okay, in this framing the problem, first we basically understand why actually we are using this project. Okay, what purpose this project solves. Okay, after understanding that, we again prepare a questionnaire on what learning should I use. Should I use supervised learning or unsupervised learning or else reinforcement learning? Okay, or else should I use batch learning or online learning? What kind of data should I require? What kind of data I require? Where should I gather all this data? So some basic questionnaire you prepare and some related answers you write over there. Okay, this is basically the first point. Second is gathering the data. Okay, basically in this gathering of data we have some few of the important points. Okay, the first point is the data is very much important to train a machine learning model. Okay, any machine learning algorithm trains on the data. Okay, it understands the particular patterns in the data to get trained. Okay, now without the data, the machine learning model is a skeleton without the brain. Okay, remember, a machine learning model without the data is like a skeleton without the brain. Okay, there is no functioning to it. Okay, now in this gathering of data we basically have few of the steps. Okay, first thing we'll be having readily available CSV or TSV files. Okay, we'll be having readily available CSV or TSV files. Okay, I'm telling it in industry grade. Okay, like industry grade example. Okay, in industry grade we'll be having some CSV or TSV files. Okay, to solve a particular problem. Okay, to build a particular project, we'll be having readily CSV or TSV files. Or second point, you need to hit the API of a company. Let's say we have Make My Trip company. You need to hit the API of the Make My Trip company and you need to request the data. Okay, hitting the API. Or else third thing, you need to do web scraping. Okay, from the same particular Make My Trip website, you need to do web scraping. Okay, web scraping. Okay, parallelly note it down. Web scraping. Fourth point, you need to access the database. Okay, with the help of permission, you need to access the database of the company. Okay, in the same Make My Trip example, you need to access, okay, with the help of prior permission, you need to access the database of the particular company. Okay, now first thing is CSV or TSV file, that is comma separator values or tab separator values. Okay, we'll be having some .csv or .tsv files will be given ready to us for just analyzing. And second is we need to hit the API of the particular company. Okay, for accessing the data we need to hit the API of the company. Third is web scraping. Fourth is, okay, through this web scraping we'll be having some JSON file. Okay, we'll be getting some JSON file, that is JavaScript oriented notation. Fourth is database. Okay, we need to access that, we need to hit the database of the particular company. Okay, now the data that will be coming from this step is the noisy data. Okay, the data in this step. Okay, in this step we gather the data, right? Okay, the data that we get is a noisy data. Okay, now this is the first point. Okay, in industry grade we basically do all these steps. Okay, but normally while we develop a project, we'll be having some particularly readily available Kaggle datasets. Okay, initially we start with Kaggle datasets, and then while we move to industry grade projects, we use these kind of steps to gather the data. Okay, but while basically preparing normal projects, we use Kaggle datasets. Okay, I'll be showing all of these steps, how to work on CSV or TSV data, or else how to hit the API of the company, or else how to do web scraping. Okay, I'll be showing all the steps, don't worry. And yes, the important point is the data that we get at this step is a noisy data. Okay, it is a noisy data. Okay, noisy data means it has some outliers, or else it has some imbalanced values, like values are of different scales. Okay, if one column is of lakhs, other column is of like thousands, okay, tens. Okay, let's say this is salary and this is age. Now salary will be in lakhs, right? Salary will be in lakhs and age will be of uh, some integer values, right? Now you can see that there is huge difference in the scale. Okay, there is huge difference in the scale. Now when a machine learning model trains on this different scale data, it may like make wrong predictions. Okay, it may give more importance to this column and less importance to this column. Okay, you basically do some standardization and normalization. Okay, that is out of context. I'll be explaining at these entire steps. Okay, but basically the data that we gather here is noisy data, unscaled data, and data with like duplicate values, and data with sorry, missing values. Okay, in this way we have some noisy data in it. Okay, it has some outliers or basically remember it is much noisy data. Okay, now training on this noisy data is not suitable. Okay, now when we train this our machine learning algorithm on this noisy data, it may produce some wrong predictions in it. Okay, it may output some wrong prediction. Okay, so that is why you need to clean the data. Now the cleaning the data involves data pre-processing. Okay, in data pre-processing we standardize or normalize, that is bring this columns into particular scale, or else remove impute missing values. Okay, when it comes to imputing the missing values, let's say we have 100 columns. Okay, when we have 100 columns, sorry, 100 rows. Okay, remember we have 100 rows. Now among 100 rows I have two rows. Okay, two rows where the values are missing. Okay, now the ratio is very small, right? Okay, out of 100% I have 2% data which is missing. So that is why what you do, you either remove the missing values. Okay, the first thing that you can do is either remove the missing values. Now let's say out of 100% of the data I have 80% of the data in a perfect manner and 20% of the data is missing. Okay, 20% of the data contains missing values. So what you do is you try to impute the missing values. Okay, we basically have various steps to impute the missing values. We will also discuss the particular steps that are involved in imputing the missing values. Okay, we do first remove the columns or else impute the missing values. Okay, and next thing is we remove the duplicate columns. Okay, we either remove the duplicate columns. Okay, and standardization and normalization. And let's say we have the data this way. We have age column, and in age I have 10 and 10. Okay, this is of integer and this is of string. Okay, when the data types are different, our machine learning model doesn't train well. Okay, so that is why what you do is you entire column. Okay, entire column should be in particular data type. Okay, entire column must be in particular data type so that machine learning model trains well. Okay, you basically handle this as well. Okay, so in this data pre-processing we entirely clean the data. Okay, this from this noisy data we produce an clean data. Okay, denoised data. From this noisy data we produce cleaned data. Okay, now this cleaned data helps in better model training. Okay, this clean data helps in better model training. Okay, which produces better output predictions. Okay, this part is a very important aspect in entire machine learning development lifecycle, because having the right data is very much important. Okay, let's say we have a model. Okay, let's say we have a machine learning algorithm which doesn't perform well. Okay, machine learning model performance is very much less, but we have excellent data. Okay, excellent pre-processed data, and we have like n number of columns. Okay, n number of available columns, and the data set is very much good. Okay, data set is very much good, but the machine learning algorithm that we used is a poor algorithm. Okay, now when we train this good data on this machine learning algorithm, it produces better results. Okay, it produces better results when compared to good algorithm. Okay, good algorithm and poor data. Okay, good algorithm and noisy data. Okay, this first case gives better results than this case. Okay, so that is why having the right data, okay, having the right pre-processed data is very much important in a machine learning product. Okay, in a machine learning project. Okay, so this is what you're doing, data pre-processing. And fourth is exploratory data analysis. Okay, exploratory data analysis. Okay, basically in this exploratory data analysis what you do is you analyze the graph. Okay, how do you analyze the graph? You analyze the graph visually. Okay, you plot the graph like bar plot or scatter plot. You do various plotting and understand the entire data set. Okay, you'll be having visual understanding of the entire data set. Okay, in this exploratory data analysis, that is EDA, first thing, we visually understand the data. Okay, we visually analyze the data. Second thing is univariate analysis. Okay, univariate analysis. In univariate analysis, we choose a particular column. Okay, we choose a particular feature and analyze the feature. Okay, we choose a particular feature, we calculate the mean standard deviation of the particular feature. Okay, now in the third, we use bivariate. Okay, similar to univariate, we also have bivariate. In bivariate, what we do is we choose two columns. Okay, we choose particular two columns and we find out the correlation between the columns. Okay, in univariate analysis, we only choose single column, but in bivariate analysis, we choose two columns. Okay, we choose two columns and find out the correlation. Okay, find out the correlation between the columns. And fourth is multivariate analysis. For this multivariate analysis, in multivariate analysis, what you do is you basically select two or more columns. Okay, here you selected two columns, here you select two or more columns and perform the you basically check the correlation. Okay, you basically check the correlation. Okay, this is basically exploratory data analysis. Okay, this is exploratory data analysis. First, you visually plot the data. Second is you do univariate analysis. Third is you do bivariate analysis. Fourth is you do multivariate analysis. Okay, you also do another thing here, that is balancing of the data. Okay, you basically balance data. Okay, what is first, before understanding what actually is balancing, we need to know what is imbalanced data set. Okay, now let's say we are building a machine learning model to classify dog or cat. Okay, for that I have 100 rows of data. Okay, in my data set I have 100 rows of data and 80% of the data has cat labels. Okay, and remaining 20% of the data has dog labels. Now this is an imbalanced data set. Okay, you see that 80% of the data goes to cat and 20% of the data goes to dog. Okay, now when you train on this imbalanced data set and machine learning algorithm, now this machine learning algorithm, what it does is, in future, okay, in future at the time of testing, even the dog image is given to the machine learning algorithm, it produces cat as an output. Okay, even you have dog image as an input image, it produces cat as an output because the cat labels are very much dominating. Okay, your model is rotting, okay, sorry, is trying to mug up the cat image. Okay, it's trying, as it is seeing much the cat image, it is trying to like mug up cat. Okay, it is trying to mug up cat and classify any image given to it as cat. Okay, this is basically imbalanced data set. What you do is you balance the data set. Okay, in this EDA you do balancing the data set, like 50% of the data should be given to cat labels and 50% of the data should be given to dog labels. Okay, this is basically balancing of the data. Okay, now till here we have completed. Okay, now the fifth is feature engineering. Okay, feature engineering or feature selection. Okay, first let me rub this quickly. Sorry, perfect. Yeah, now fifth is feature engineering and selection. Okay, we have two components over here. Okay, first is feature engineering and second is feature selection. Okay, in feature engineering, what you do is you basically create new features. Okay, in feature engineering you create new features. Okay, how do you create new features? Let's say we have length, breadth. Okay, length, breadth as two columns. Okay, now you can combine this length and breadth column to area. Okay, from this length and breadth column I'm creating a new feature of area. Okay, from this length and breadth feature I'm creating a new feature of area. Okay, so due to this, what actually is happening now, how much impact these two columns are showing, the same impact is shown by this area column. Okay, on the model results, how much these two components are contributing. Okay, how much these two features are contributing, the same contribution is done by this particular feature. Okay, due to this, what actually is happening, the dimensionality is reduced, right? Here we have dimension of 2, here we have dimension of the 1. Okay, so that is why dimensionality is reducing. Okay, reduced dimensionality means more good model performance and less training time. Okay, less dimensionality means less training time. Okay, less dimensionality means less training time and good performance. Okay, this is basically feature engineering. Okay, in feature engineering, what you do, you basically create new features. Okay, from the old features or available features you create new features. Okay, now after feature engineering is done, you do feature selection. Okay, now let's say we have around 2 to 300 columns. Okay, 2 to 300 features. Okay, now 2 to 300 training and machine learning algorithm on 2 to 300 features is a costly way task, right? It is highly computationally expensive, and also training time also increases. Okay, sorry, it is computationally expensive and also training time increases. Okay, now among these 2 to 300 features, all the features may not be important. Okay, so what you do is you remove the features. Okay, the features that are not important, you remove those features. Okay, now let's say out of 200 features, like 50 features will be definitely unnecessary. Okay, out of 200 features, 50 features will be definitely unnecessary. So what you do is you remove those columns. Okay, you remove those columns and save this data set into some other variable. Okay, this is basically what you do in feature selection. Okay, in feature engineering, you create new features. After creating the new features, you select only few features from it. Okay, now after getting this area, okay, after getting this particular area column, I'll be also having this length and breadth, right? Okay, after even having this area column, I'll be also having length and breadth. Okay, I need to remove these columns. Okay, this is basically done in feature selection. Okay, in this way you basically remove the columns. Okay, after creating new features, the remaining features are removed. Okay, so due to this, data becomes clean. Okay, now till here we have entirely worked on the data. Okay, first we have noisy data. From the noisy data, we have cleaned our data by data pre-processing, and then we have studied our data. Okay, then we basically studied our data. After studying the data, we have then analyzed our features. Okay, what features will be important to our machine learning model and what features would not be important to our machine learning model. Okay, the features that aren't important to our machine learning model are basically trashed out, and the features that are important are being selected. Okay, this is basically done in feature engineering and selection. Okay, till here we have entirely till here we have entirely worked on the data set. Right, now starts the work of model. Okay, first we need to after completing this data preparation step, we need to work on machine learning algorithm. Okay, first is model training. Okay, now in this case, okay, in framing the problem, we basically choose some algorithms. Okay, now let's say we want to solve a classification. Okay, in framing the problem, we have observed that our problem is a classification problem. Now to perform this classification problem, you basically use logistic regression and SVM. Okay, these are some basic algorithms that you use to perform an classification task. Okay, that for that particular question, okay, what are the algorithms that are used to solve this particular problem, you basically choose two algorithms, that is logistic regression and SVM. Okay, in this step you basically choose two algorithms. Okay, after choosing these two algorithms, at this step, okay, you come to this step, and what you do is you basically train. Okay, on the data set that you have entirely prepared, you will train this machine learning algorithms on this data set. Okay, both these algorithms will train on this common data set, logistic regression and SVM. Okay, both these algorithms will be trained on this particular data set. Okay, they will be having some common data set to get trained. Okay, now this is model training. Okay, in model training we choose the algorithms. Okay, on that algorithms we'll be training our common data set. Okay, just we'll be doing entire training process. Now second comes evaluation. Okay, now as we are performing classification, okay, when it comes to classification, we'll be using the metric as accuracy score. Okay, now let's say logistic regression has produced 98% of accuracy and SVM has produced 97% of accuracy. Okay, as accuracy is our metric, we evaluate in terms of accuracy. Okay, now logistic regression has given me better accuracy, right? Okay, so that is why what you choose logistic regression. Okay, you choose logistic regression as your algorithm to solve this problem. Okay, to solve this classification problem. Okay, now if you use regression, okay, when you use regression, you basically use loss. Okay, loss as your evaluation metric. Okay, loss is nothing but like mean squared error loss or hinge loss. Okay, in this way you use various loss as the evaluation metric. Okay, as we have classification, we use accuracy as our evaluation metric. Okay, now till here we have chosen our algorithm. Now after choosing our algorithm, we choose hyperparameters in it. Okay, after choosing the algorithms, we'll be having some hyperparameters in the particular algorithm. Okay, now this hyperparameter helps in improving the performance, okay, improving the results. Okay, we have 98% accuracy. This accuracy can be further improved to 99%. Okay, this 98% accuracy can be improved to 19% by hyper tuning. Okay, by tuning this hyperparameters. Okay, this is basically called hyperparameter tuning. Okay, any algorithm has some hyperparameters. By tuning this hyperparameters, like checking out different values, okay, testing out different values of this hyperparameters, we can further improve. Okay, we can further improve the performance of a machine learning algorithm. Okay, now this is the model selection. Okay, in model training we choose the algorithm. Okay, we'll be training on various algorithm, and in evaluation, based on the evaluation metric, we choose some particular algorithm. And in selection, after choosing the particular algorithm, in that algorithm we'll be having some hyperparameters. We basically tune this hyperparameters. Okay, we choose different hyperparameter values and test out. Okay, we choose the different hyperparameter values and test out until we get the best results. Okay, until we get the best result and best hyperparameter values. Okay, optimized hyperparameter values. Okay, till now we have our model ready. Okay, our model with better accuracy. Okay, with best accuracy. Okay, optimized model is ready. Okay, till here we have our machine learning model. Okay, now after having this machine learning model, keeping it on the local machine doesn't give anything. All right. Okay, after having this machine learning model, after working on an entire project, if we have that entire project on a local machine, that is useless, right? We need to develop an end product from this machine learning model. Okay, we need to get ready and machine we need to get ready an website. Okay, from this machine learning model, we can develop an website, or else app, or else software. Right, we can do various things with this machine learning model. Okay, that is done in model deployment. Okay, basically what you do is you build an product. Okay, you build a software product from this model. Okay, from this machine learning model, you basically build a software product and give availability to the public. Okay, so that public can access. Okay, you basically deploy it on the server and public can access through the server. Okay, now here what you do is first you build the front end. Let's say you're building a web application based on your machine learning model. Okay, first you basically build front end by HTML and CSS, then build API using fast API or Flask API, and then backend. Okay, then we build backend. Sorry, then we build backend. Okay, first let's say we are building a web application. In web application, we have a front end, API, and backend. In the backend, we have our data and our machine learning model. Okay, this API used for communication purpose. Okay, this API is for communication purpose. This front end is accessible to the users. Okay, this front end is basically accessible to the users. Okay, now this entire thing is called machine learning end product. Okay, this entire thing is called machine learning end product. Okay, this machine learning end product is basically deployed on the server. Okay, we have various services like Amazon AWS service and Google Cloud services. Okay, sorry, in this way we have various services so that other users can get access to this end-to-end machine learning product. Okay, end-to-end machine learning product, this is basically done in deployment. Okay, in deployment you give your machine learning end-to-end product access to public users. Okay, this is called deployment. Okay, this is called deployment. And it is testing. Okay, this testing is also referred as beta testing. Okay, this testing phase is also referred as beta testing. The best example is, now we have various versions of Android, right? Okay, like Android 18, Android 17, Android 16. Okay, we basically have various versions of this Android. Okay, now before launching it publicly, okay, before making this publicly available, they will select few users. Okay, they'll be selecting few users and they will roll out the update before launching it publicly, right? Okay, we basically if you have some app, okay, first in Play Store we'll be having beta version of this app. Okay, we'll be having some beta version of this app. Okay, in beta, after download, okay, after people downloading this beta version of the app, they basically give feedback to the company. Okay, they basically give feedback to the particular company who have developed this app. Okay, like what are the bugs in it, what are the improvements that can be done in this particular app. Okay, so this is called beta testing. Okay, this is basically referred as beta testing or beta testing. Okay, they, what they'll do is they'll particularly they'll have some set of users, they'll particularly roll out the update to the particular users, and based on the bugs they have, and based on the features that can be improved, okay, based on this they'll be giving the feedback to the company. Okay, they'll basically give the feedback to the company and company will try to resolve the issues. Okay, this is basically done in beta testing or testing. Okay, the famous technique is A/B testing. Okay, the famous technique in this beta testing is A/B testing. Okay, we'll be also seeing this A/B testing in detail. Okay, don't worry. And ninth is optimize. Okay, this step is very important step, because what you do is, in this optimization step, what you do is, after deploying your model on the server, okay, after basically deploying your model on the server, you will be backing up the model. Okay, like what you'll do is, after deploying the model on the server, okay, after deploying the entire machine learning end-to-end product, what you'll do is, you'll back up the model, you'll keep the backup of the data. Okay, you'll be keeping the backup of the model, you'll be keeping the backup of the data. Okay, and what you'll do is, let's say your machine learning software has broken. Okay, let's say some issue has occurred. What you'll be doing is, you'll be bringing it offline and solve the issues and retrain it on the like some new data is available, you will be retraining it on the new data, and again you bring it online. Okay, this is basically done in optimization step. Okay, now this optimization step is important, because now let's say we have email spam classifier. Okay, we have email spam classifier. Email spam classifier. Now we have built this email spam classifier in 2020. Okay, right before the COVID, let's say in 2019. Okay, right before the COVID, we have built this email spam classifier. Okay, now the same email spam classifier model cannot be used in 2025, right? Okay, as the model is old, the spammers got evolved. Okay, as spammers got evolved, and the machine learning model, that is email spam classifier, is very much old, we cannot use this model right in 2025, right? So what you do is, you take this, okay, you bring this email spam classifier model offline and again retrain it on the new data set, and again you will be making it online. Okay, this entire automation is done in optimizer. Okay, in optimization step, again you have another important point, that is, you'll be like you have made your machine learning product. Okay, machine learning project, like which is available to how to say, like 10 to 20 users can easily use this machine learning project without any server issues. Okay, without any server issues, they can use very much comfortably. But when suddenly, okay, when suddenly traffic comes to your website, okay, when suddenly traffic comes to your website and some thousands of users are ready to access your website, then you you need to some basically do some optimization. Okay, you need to improve the scale of the project. Okay, you need to basically improve the scale of the project. Okay, even that step is done over here. Okay, you basically improve the scale of the project in this step. Okay, in the first step, we basically frame the problem. Second is gather the data. Third is data pre-processing. Fourth is exploratory data analysis. Fifth is featuring and selection. Till here, we entirely work on the data. Okay, we basically do our entire concentrate on our entire data set 50% of the time. Okay, when the data is ready, we then switch to model. Okay, we then switch to model or other components of the project. Okay, we then choose our best model over here. We basically deploy it on the server and make availability to the public users, and we use testing, that is get feedback from the consumers. And ninth is optimization. Okay, we basically handle the traffic to our website, or else keep the model backup and again retraining it when it is online. Okay, you basically do this automation in the optimization step. Okay, these are all the steps that are in machine learning development lifecycle. Okay, this is the these are the common steps that are followed by any machine learning engineer. Okay, any industry grade machine learning engineer will follow basically these 9 steps. Okay, will basically follow these 9 steps. Now if you are working on any industry grade project, now for framing the problem, you'll be having some particular team. For gathering the data, you'll be having some particular team. For data pre-processing, you'll be having, let's say it's a large scale project. Okay, in this large scale project, each step is performed by, okay, these 2 steps are performed by some particular team, these 2 steps are performed by some particular team. Okay, in this way this kind of individuality is maintained. Okay, this kind of individuality is maintained in a machine learning project. Okay, this is basically entire machine learning development life cycle. Hope you guys like this video. If you like the video, please like, share and subscribe. Thank you.